Hey guys, today we're going to do 3-4 properties of logarithmic functions. So we will learn about the properties of logarithmic functions. Properties of logarithms. Let b, r, and s be positive real numbers with b not equal to 1 and c be any real number. We have the product rule. So if we have the log base b of r times s, we could expand this log from a product to two separate logs of where we're adding them. So it would be log base b of r plus log base b of s. Quotient rule, so if we're dividing, then we subtract our two logs. And then the power rule, if we have r raised to a power, we can bring that power to the front. So it would be c times log base b of r. These are very important. Write the expression as a sum or difference of the logarithms or multiple logarithms. So here we have power. We have products. So we can take the log of 8 plus the log of x plus the log of y to the fourth power. This fourth power comes to the front, and we have log of 8 plus log of x plus 4 log y. Log of 8 is equal to 3 log of 2. If we use our calculator, this is what happens. And log of 8 is equal to 3 log of 2. 3 log of 2 could be log 2 to the third power, which is equal to log of 8. And we see that the value of these two are the same. ln of 8x is equal to ln of 8 plus ln of x. We could then take 8 and rewrite it as ln of 2 to the third plus ln of x. And I can take the 3, bring it to the front, and I would have 3 ln of 2 plus ln of x would be fully expanded. The same thing for ln of 9y. 9 can be rewritten as ln of 3 squared plus ln of y. Bring the 2 to the front. 2 ln of 3 plus ln of y. Write the expression as a sum or difference of logarithms or multiple logarithms. So I have this division, and the division will then be written as subtraction. So ln of the square root of x squared plus 5 minus ln of x. This square root can be written as ln of x squared plus 5 to the 1/2 power. I bring the 1/2 to the front, and it would be ln of x squared minus x squared plus 5 divided by 2 minus ln of x. We can't separate this here because it is not ln of x squared plus the ln of x of 5. It is the ln of x squared plus 5. So this quantity stays together. Then we have the change of base formula. So the change of base formula will let us evaluate any log. So if we have log base b of x, we can rewrite it so that we have log, a common base of x, over log, common base of b. So the x would go in the front in the numerator, the base would go in the denominator. A is usually 10, our common base, but it can be any number as long as it is the same in both the numerator and in the denominator. How would you solve? Log base 4 of 7 is equal to y. Well, if we wrote this in exponential form, 4 to the y power is equal to 7. I have no idea what power I could raise 4 to get 7. Therefore, I could do the log of 4 to the y power is equal to the log of 7. So I logged both sides. I could bring my y to the front. So I have y times the log of 4 is equal to the log of 7. I'm going to divide by the log of 4. And we get y is equal to the log of 7 over the log of 4. If you look at this, that's the same thing as my change of base formula. And in my calculator, I would push log 7, close parentheses, divided by the log of 4, close parentheses, and I get my decimal value of about y is equal to 1.404. And if I check it, it works, but when I show you that 4 to the 1.404 power is very close to 7. That's all.